So this is a corrosion application. We're going to be making today for you a light RTM process, by light RTM process, a pipe nozzle.
What we've done in this mold here is we've put the silicone plate in place. There are pilot holes in the mold that is taking a pin. This slides over top of the pin so that it comes down and it seats on this. It's almost 1/8 of an inch longer than what the cavity thickness is when it's closed. So what happens is when we compress this, we seal it off so we don't get resin on either side. So therefore, you know, when we pulled these out on a 24-inch flange, we found that there was like about 20 thousandths deflection in a distortion rather, in the flange detail itself, which meant that they didn't have to machine it, so then they didn't have to come back and hot coat it. I mean, you're just taking other steps out of it. Not to mention that this is something brand new that we're doing, but the larger one we've done, and again, I think we have calculated it's about 1 hour and 20 minutes to do a 24-inch flange of labor from start to finish. A couple other things to note is we have our zero shutdown here and here, and then this will be our cavity for clamping. The other big thing is that we have a resin runner, so this runner comes in, we're going to inject here with the auto valve. It's going to come in, it's going to run around this channel around the outside, and then it's going to encapsulate and close in to the end of it. So let's put it on. Turn it.
While Doug gets the vacuum to engage, I'm going to start talking a little bit about what we've got in there as far as a kit. We had our partner UB cut us out a kit so that it's ready to go. You'd want to have some pre-kitted out system like this with the fabrics that you're putting in. Recall that we're trying to come up with an analog to the hand laid up call out for the specification for these, which is typically a veil, chop strand mat in a hand laid situation, and woven roving alternating. Pretty old technology. Also, those type of materials don't flow well under vacuum. So while we can use the same veil, this is a Nexus veil piece of the kit here, and what we do there to try to remove the fiberglass from the surface, remember it's the resins that's giving us the corrosion resistance, is we stack a multiple numbers of veils. But then we get into the structure of it, and we're using a product from Owens Corning called Uniconform. It's an all glass product that it's very conformable. It allows the resin to flow through it well. We're alternating that with a vector ply, ETLYA 3612. It's an engineered fabric, and we alternate these layers to kind of simulate what the performance would be in a hand laid. Actually, it exceeds it by a lot, and there's an opportunity to actually take some thickness out of these parts. Remember, these are all crudely modeled after cast iron, so the specs for flanges were based on that. So we're not taking full advantage of the composites capability. That's going to require changes to those standards, which we're challenging them on that now. Just like every other industry in this room today, composites is still the new guy on the block. The engineers can't look it up in a table like they can cast iron or steel or aluminum even. It's got to be, it's a designed and an engineered product. So we're still not taking full advantage in this. These type of products could be made at half the thickness and have twice the strength at least.
Here's a big 26 plant petrochemical complex in Saudi Arabia. This particular project, every single piece of FRP equipment that was used in this project was used with an Ashland resin. And one of the resins that was used in this project is the exact resin that we're using for today's demonstration. It's a Derakane 411 epoxy vinyl ester resin. It is an industry standard resin, widely used, very popular because of its wide range of applications and end uses. It's used for things from tanks to pipes to scrubbers to ducting to custom components.
Doug's got us all set. We've got the kits put in of the fabrics. Doug's got the vacuum system in place. What's going to happen over here with the pump?
All right, so right now it's actually recirculating. This is something we like to do before we ever inject a part. We It shows us that both of our resin pumps and our catalyst pumps are working. You can see in a sight tube over here, we're getting catalyst flow, and we have a sight tube on our resin drum. You can see that we're getting resin, so it's telling us the pumps are working. We have a couple safety things built into this machine. We have an MPG, so when we go to inject, if we sense any back pressure and the resin's not flowing the correct way in the part, it's going to slow down the pump. And it's not going to allow any more resin to go into that mold until that pressure is relieved. And then it'll start pumping again once that pressure is relieved. So when we hit inject, there's going to be a gold piston that pops up out of that valve. When that opens up, it's opened up to the mold then. So resins will then go into the resin channel and start filling the mold.
That's the peripheral clamping pressure. When I get to 10, I'm going to release it. Now, if this is something new we've changed, we put bigger gauges on these units now, so they're easier to see from a distance instead of trying to look at this really small gauge. So after I release this, I want to make sure that I don't have anything that moves that needle. If the needle didn't move, if it would have moved, if it would have dropped, then I know I have a leak somewhere in my system here, and I don't want to inject it until I find that leak. So, we're ready. Inject. See the pin open, so visually you know that your cylinder's open, so we're communicating to the mold. Resin's coming through the line. It's going around the peripheral, around that resin runner that comes around here. And now it's starting to feed into there, and it feeds into the product. So after I'm injecting this, I could go and fill this one and get all the load put in and be ready. So as soon as this cures, I can pop the B side out, go on to my next mold, plug it in, and inject it.
Now it's going to just flush into our waste bucket.
You do all the hard work.
That easy, man. I get to stay clean. I like it.